simple question today is very simple. All we're doing, guys, can I solve?
I can't find it. Oh, this is one of those.
You. Guys, all we're doing, can I solve logarithmic and exponential equations? So we'll do this a couple of ways. I don't know why we're tossing water all over the way around. I don't know when you just point it. Can I solve logarithmic and exponential equations?
Yes.
So there are two properties I want us to go over. Wait, there's two properties I want us to go over. They're in fancy math language, but they're actually super easy. You don't even have to memorize anything. They're just kind of common sense more than anything. Amelia, John, how we doing? So, property of equality, if b is a positive number and it's not 1, so any positive number other than 1, golden. Alright, and b to the x equals b to the y, well that means b is equal to b, right? That means that x is equal to y. Alright, so example, if I have 3 raised to the power of x, I don't know what x is, and I say, or it's said to be through math, that is equal to 3 to the 5th, then x has to equal 5. It also works vice versa. You see that on the next one. If x equals 5, and 3 to the x equals 3 to the 5th. You just know that, right? So, in terms of solving, so I'm given an equation, a, so this, oh, I'm sorry, not a, this is a, if 2 raised to the x plus 3, that's an x, equals 2 raised to 2x. So I know my b, both my b's are equal, right? Does 2 equal 2? Yeah. Right. So I'm saying that the exponents that they're raised to also have to be equal. So in terms of solving this, I don't even need exponents. Due to this equality law, I can just rewrite this as x plus 3 equals 2x. And now it's algebra you learned in, what, 8th grade? Yeah. Right?
Yeah, I didn't take algebra.
So if I subtract x from both sides, x equals 3, right? Is that all I do for that? Just subtract x from each side?
Wait, is that really it?
Yeah, that's really it. Okay, yeah. What about b? Alright, so Trent's on to something. Trent, the problem with this is my bases aren't equal, right? I can't just multiply each side, right? If I'm multiplying each side, so let's say I multiplied this side by 2. Well, 2 times 2 is now 4, right? But I also have to multiply this side by 2. So I can't, there's nothing I can do to each side to make them equal. However, can I make a 4 look like a 2? Yeah. What is 4 in terms of 2? 2 times 2, 2 squared, right? So what if I rewrite this? So I've got a 2 to the x plus 1, right? And I want a 2 squared, right, x plus 3. Now that still isn't just 2, it's 2 squared. But what do I do with exponents when they're raised, with an exponent raised to an exponent?
Multiply it.
I multiply. So do I need to distribute that 2?
Yeah.
So is this really 2 to the x plus 1 equals 2 to 2x plus 6? Everyone see what I did there? I took that 2, it was raised to the x plus 3 power. Since I'm multiplying, right, I'm raising an exponent to an exponent, I have to
That keeps
distribute.
it equivalent?
Yeah, and that actually does keep it equivalent. I haven't done anything to the left side. I've done totally legal math here. I'm just working on one side.
Put a 2 in for x, it will equal out on both sides.
Do what?
If you put like, okay, after we before we find out what x is, we put that number in the very.
We're not done. I still have to solve for x, right?
Yeah.
But now are my bases the same?
Yeah.
So now I'm going to rewrite this without my bases and just say x plus 1 equals 2x plus 6. I can say my exponents have to be equal. So solve for x, negative 5. Subtract x from both sides, subtract 6 from both sides.
Like, are you x 4?
Good. So this next one, 3 to the x equals 1/9 to x plus 3. So I can't just do things to both sides. I just want to pick one of these bases, right, and make it look like the other. Let's work with 1/9. All right. So I want it to be a 3. So I want a 3 to the x equals a 3. I'm going to raise it to an exponent, right? And I'll still have this x plus 3. What would I raise 3 to make it equal to 1/9? What would I raise 3 to? What power to make it 1/9? I definitely need to reciprocate, right? I need a 1 over. So it's going to be a negative exponent. All right, so a negative 1 would make it 1/3. Yeah, negative 2. So 3 to the negative 2 power is just a different way of writing 1/9. Right, Ashton?
Yep.
What is 3 to the negative 2 power?
Sorry. Where are we at? Where are we at?
Good question. Lucky. Do you want to move back here? Sean's not here. There's 3 desks. I'd be more than happy for you to fill. The whole side feels kind of lonely. Yeah.
Oh, I was giving him the answer. I'm sorry.
Great. Well, before that, you were keeping him from getting the answer. Quit distracting. I need to make 1/9 look like 3. And I need to make 3 equal to 1/9, right? So I raised 3 to the negative 2 power. I'm going to do what I did up here, right? And I like these little boxes. So I'm going to distribute that negative 2. So 3 to the x equals 3 to what power? I need to distribute the negative 2. So what's my new exponent? Negative 2x minus 6. And now are my bases the same? Right, good. Yeah, we're good. So x equals negative 2x minus 6. Add 2x to both sides. 3x equals negative 6. So x equals negative 2. Yeah, that'll be negative 6 over 3, which I'll reduce to negative 6. I mean, you at least need to show me how you changed your 1/9. So you at least need to show me your new base, and then you need to show me your distributing, and then I'm okay if you skipped from that to here. But there's a lot of work you actually have to show me on this. Good. Solve for x. Show your work. So 4 to the x equals 11. So this is giving me a number 4. My base is 4, right? And it's saying raised to an exponent. We don't know what, but we know it equals 11. Think back to your definition of a log. I had a base b, log base b, right? And I said I wanted to get to a number x, right? So I had my base b raised to an exponent y equals x. This is saying my base b raised to an unknown exponent equals 11. So can I just take this immediately, rewrite it as log base 4, right, because 4 is my base. I don't know what exponent I'm raising to, but I know what number I want. I want to get to 11. This is just, guys, this is just the definition of a log. Victoria, Riley, we good? Yeah. No, I want to solve for x, right? Can I plug log base 4 of 11 into my calculator? Yeah, for those of you with the old ones, do change your base. So x equals log of 11 over log of 4. All right. For those of you with new calculators, just do option A, change your base to what, 4, and then find out 11. They're not expensive.
How do you put in your
So for those of you with the new ones, I wasn't recording, but now I am. 1.73. Good. Do the next one on your own, just like it, right? The next one on your own, you can change that to a log form. All right. On your own. Okay, everybody. So if I'm going to rewrite this as a log, I have log base what? Ashton, log base what?
No.
Log base 7, right? Guys, the base for my exponent is always the base for my log. So log base 7 of 15 equals 9x. Okay? So I'm saying 7 raised to 9x equals 15.
You just switch 15 to 9.
I didn't switch 15 into 9. I'm just saying the same thing. This is just the definition of a log. 7 raised to 9x equals 15. 7 raised to 9x equals 15. That's just the definition of a log, guys. Good. So what was log base 7 of 15? 1.39 equals 9x. So then divide each side by 9. X equals 0.15, right?
Wait, why wouldn't you put log 7 over? Oh, I'm just kidding. You know what I did?
What?
I put x equals log 715 over 9, and then when I put that in my calculator, it gave me 1.4 because the log 7 and the log 15 were both over 9.
Yes, that will be different. Okay. Wondering when you'll use this? What? So, when you'll actually use this? Back to money. If $10,000 is invested in the money market, an account that pays 8.75% interest, compounded weekly, how many years will it be until the balance? You can just not do it. You can figure it out on your own. How many years will it be until the balance is $250,000? So if you've been sitting around going, all right, well, I've got this much money. I'd love to have this much money. And you look at all these different accounts and you go, how long would I have to put my money in here and not touch it until I have this much? So if someone gave you $10,000 and said, someday you'll buy a house with this, it'll be $250,000, go, I wonder how many years that would be. So go through, let's go through what we know. What is P? Principal, right? 10,000. T, I don't know, right? That's what I want. How many years? T in years. So we'll find T. We'll put a question mark next to that. I know my rate in decimals. What is it?
0.0875.
0.0875. Okay. I know N, don't I? How often?
250. Oh wait. No,
How
no.
often is this compounded? Weekly. So what is N? 52. 52 weeks in a year, right? And I know A. Guys, I know how much money I want to wind up with, right? $250,000. So let's write it out. $250,000 equals 10,000. 1 plus 0.0875 over 52 raised to t times 52. So t is what I want to solve for, Amelia, and t is an exponent here. The only way to solve for exponents is with logs. So I want to get it as small as I can with the exponent, right? As small as I can with everything leading up to the exponent, and then I'll use a log to get just my exponents. It's a principle I won't really go into. I just kind of want you to take it and know that this works, okay? So what's the first thing I want to do here? That's the last thing I want to do. How am I going to... Yeah, I want to get 2 by itself. So I want to get rid of that 10,000, right? You can't just... Okay, can't just get rid of it. So let's get rid of that 10,000, okay? So 250... Yeah, 250k divided by 10k is 25. 1 plus 0.0875 divided by 52 raised to t times 52. All right, well, if I can, I want to simplify this down to one big number, right? So what is 1 plus 0.0875 over 52? Now I'm working down here because I'm on a room. 25 equals... If we plug that in, what do you get?
Wait, if we multiply it all by 52, would that be wrong at this point?
Yeah, because 52 is an exponent.
No. I mean the thing that's dividing by 52.
Yeah, that wouldn't do anything because you'd have to distribute that 52 to this. So that will do nothing. And plus you'd have to apply that 52 after you apply the exponent.
Okay.
How come that equals?
All right, hold on. We got an answer. 1.001. Keep going. 1, 6, 8, 3.
Is that one? Is your guess?
Yes.
Wouldn't it be minus 10,000?
No.
No, because you're timesing it by that.
You're multiplying by 10,000, so we divided by 10,000.
You're not adding it to that.
We're having like widespread just algebra 1 issues right now, guys. I don't know what's happening. We're just solving for x. You good, Christian? Good. Folks, the reason, Carly, that I need all these decimals, all right, is for accuracy. When you're doing what we're going through right now, Ashton, you've got to have as many decimals as possible, because what I'm going to show you, okay, the only way to get these guys by themselves, that t and that times 52, I want them by themselves and not as exponents, is to take this property of logs. I'm going to rewrite this 52 times t. I said that using logs is just another kind of tool in your belt for solving problems. This is the way it's going to work. All right, I'm going to take a log of each side. All right, and the log base is what's important. The base is going to be this big number. So log base, and stay with me, 1.001683 of 25, right? So I'm going to do that to each side. I'm going to circle it in red ink here. This log base is the operation I'm doing to each side. So log base that equals, I'm going to write it again, log base 0.001683 of this guy, right? 1.001683 raised to 52 times t. Okay. Stay with me, it'll be fun. The stuff in red, that's the application. I'm taking both sides, right? So without the red, minus the red, it's just up there. Okay, so I'm taking a log of each side. So, yes. So I've done a log to each side, right? So in blue is the stuff that stayed the same, right? Everybody see that?
Yeah.
Okay? Here's the property, and I'm not going to go through and show you exactly why this works. I'm not too worried about that. You just need to know when I have a log with a base, and that base is the same as my number, all right? This all disappears and becomes so log base 1.001683 of 25. What disappears is all this, and all I get is 52 times t. That's the property. When I take a log base, and that base is the same as the number I'm doing the log of, all that's left is the exponent. Sometimes that exponent is just 1. Think about it like this, guys. If I do log base 8 of 8, what is that? What exponent do I raise 8 to get 8? 1. So it just disappears, right? You can think about them in terms of canceling, because this whole thing cancels. But log base a number of a number, it's just going to give you whatever that exponent is. So all that's left is this, 52 times t. Yes, that's a t. Finally. Can I do this in my calculator? You betcha. Do it. What do you get? Log base that ugly number of 25.
I'll be honest, that comes with that homework or that numbers.
You're really not going to do well, Ashton.
I know.
And I'd like to point out that I have you on camera saying that.
Which class is it going to? Just everyone?
Everyone could see this.
Everyone.
I could say your parents could get on D2L and hear that.
What did he say?
Hi, Mr. and Mrs. Brady.
That was Ashton, by the way. Ashton Lee
Your
Brady.
son's getting up.
Hey, Daddy, we're doing that in life. I need a little fee for the rest of my life. Can I live in the basement?
What do you get?
You already live with me.
Exactly.
I got 1914.1.
I'm just going like this.
Good. Okay, that's fine. 52 times t. Wow.
I got 1914.
So guys, if you do that, listen up. If you do that log base, whether you do change of base or whether you go into your calculator and change it, you get 1914.191176. This is one, guys, this is the only exception to where I say round where you want. If you start rounding at the tenths or at the hundredths place, you're going to get really inaccurate values. I'll be able to see most of your work, but your final answer will be so far from mine, I can only give you partial credit. This is where, in a question like this, I need all the decimals you can give me. Right, all of them. So then all that's left is to divide by 52. So how many years will it be till we get 250,000? 36.8 years. Good. So this part is like the properties with exponents. Properties with exponents, where I said if my basis is the same, I can set my exponents as equal, right? It's the same for logarithms. If I have two logs and their bases are the same, and I'm saying that they're equal to each other, I can set the number I'm logging as equal. So if I have log base 5 of 4x minus 7, and I say that equals log base 5 of x plus 5, what do you think I can set as equal to each other? 4x minus 7 equals x plus 5. As long as I have the same base, doesn't matter what the base is, it can be 9, it can be 9 million, it can be z, it can be literally anything, but if I say that the bases are equal, and both sides of the equation are equal, I can just set those logs. So, just solving for x, what do we get? Because clearly we need some practice, so go ahead.
Add 7.
Let's see. Good. X equals 4. Okay. What do the directions for this problem say? Solve and check. there are extraneous solutions. Here's the nice thing, guys. You aren't going to check just by plugging it back in. There's actually very little to no math you need to do to check. Checking is easy. I'm not necessarily checking for extraneous solutions. I'm checking to make sure that my answers fit inside my domain. With exponential functions, I limited my y's, right? My range. With logarithmic, I'm limiting my domain, my x. So I have to make sure this answer fits back in. So for each side of my equation, I need to see what I've restricted to. So what numbers do I look at in logs to see where my asymptotes are? Not K. K moves me up and down. H. H. So what is H in this first one? Yeah, +7. I need to change it. So it's not just +7. What else is in that little pesky guy there? There's a 4x, isn't there? You almost do, you guys, you just do this like you're solving for x, like it's a 0. So +7, and then what do I do with that 4? Just divide. So x has to be greater than 7 over 4. Is 4 within my domain then? Is it bigger than 7 over 4? Yes, but I have to do the other side as well. What is my restricted domain for the other side? X is greater than what? -5. So does this answer work? Yes. So it's not, the checking for solutions is just take both sides of your equation, make sure they fit inside your restricted domains. So what do we get for x? 5. No problem. Anybody not get 5? Want me to show them?
I got 5.
Did anybody not get 5? Good. Now everybody, because we're struggling lucky with domain and range. So everybody watch, okay? I don't plug 5 in to check. Okay? Mostly because it's too much work, but also because this is more foolproof. Guys, I just want to find out what my restricted domain and range is. So find out what your h value is. What's h here? 8. It's -8 though, right? Change the sign and then divide by your coefficient. So x has to be greater than what?
4.
-4, right? It's -8 divided by 2. So the other one, I've got an h of 12, right? +12. What's 12 divided by 6? 2. So x has to be greater than 2. Does this answer work for both of those? Yes. So that is an acceptable answer. Yes, Alex.
Is it always going to be x is greater than a different?
Yes, it always will. It always, guys, it always be greater than, because even if I have a -a, it flips it across the x-axis, not the y-axis. Good. So, solve and check, show your work. Log base 4 of 5x minus 1 equals 3. So what's different about this one, Ashton?
You don't have a set, like...
Yeah, I don't have a log on the other side. Yeah, it's still just solve. Guys, what is this asking me? Go through your logs. All right. Log base 4 raised to the 3rd power equals 5x minus 1. Can I just rewrite this as an exponent? So what's my base? 4 raised to what power? 3rd equals what? 5x minus 1. And now, just 4 to the 3rd is what?
64.
64. Plus 1 is?
65.
65. And then divided by 5 is a little tougher. It's what? 13. So x equals 13. Check your answer, guys. We got to check our answer. I need to find out my restricted domain. X is greater than what? What's my h? 1. +1. Change the sign. Divided by 5. 1/5. Is 13 bigger than 1/5? Good. Do the next one on your own. All right. What did we get for x?
17.
Anybody not? Did anyone not get 17 and want me to walk us through?
I got 17.
Are we good? No. Does 17 work? Brent, does 17 work? I know. What's your restricted domain? Guys, Colton, what's my restricted domain? X is, well, not equal, my bad. X is greater than what? Colton, do you know how we got 2/3? Okay. So does 17 work? Good. Alright. Alex, solve and check.
Yeah, Alex.
Show your work.
Alex for the race.
Trent, what's different about this one?
Where's she going? I'm like, oh, we had water bottle.
Oh, can we all just give Trent a hand? Yeah. Alright, stop. Okay. Does anyone know why we're giving Trent a hand?
No.
Listen up. Trent, say that again. What is different about these two problems?
You used notes from last time, so the formulas you gave us, floating power and.
Good. So this looks like last time because not like last time. It looks like this guy here, right? I've got a log on one side equal to just a number, but I have two logs. So there's a longer calculus-based method of solving this with two different logs. Or what's the base on both of my logs? And what they're being added, right? So can I just combine that into one log of log base 6 of 3x of x minus 4, and then distribute that? You've got to distribute, you guys. So log base 6 of what? 3x squared minus 12x. Good. Equals 2. Okay, and this is in parentheses. I don't want you to think of that minus 12 on the end there.
12x.
Good. Now, 12x. Thank you. My bad.
I didn't say anything.
Okay, so now, guys, look at it. Log a number equals 2. Can I do exactly what I did here and just set it up in exponential form? So what's my base? 6 to what power? Squared equals what? That's 12x. Good. What's 6 squared?
36.
36 equals 3x squared minus 12x.
Now you can subtract the 36 over.
So if I subtract the 36 over, I'm equal to 0. And then can I factor and or use quadratic if I have to?
Yes.
Oh, I'm bringing it back.
This was my least favorite part of that.
All right, let's factor this.
Bring it back.
What can I pull out of every number?
Shoot.
Oh wow, you're going way
He's
back.
throwing back.
Leaving me with what?
X squared minus 4x minus 6. 6. Oh no, just kidding.
Wow, lucky, you made me say that now. I feel stupid.
Good, so use AC method. I need to get to what? Negative 12? What do you got that'll get to negative 4? I need the factors of negative 12. So 1 and 12 won't work. What about negative 6? Negative 6 and positive 2? So x minus 6. Blah. X plus 2. Let's see, that'll get me my x squared. There's a negative 12. I'll have a negative 6x and a positive 2x. Good. So what does x equal? Negative 2 and positive 6. Good. We need to check. Especially now that we have two answers. We have to check. So negative 2 and 6. So let's go back up. Still have two logs I need to restrict. This first one's pretty easy. X has to be greater than What's h in that first one?
0.
0. So even what's 0 divided by 3? 0. And what's this guy? X has to be greater than positive 4. So 0 and 4. Which of these doesn't work? Gotta check. I can only give you partial credit if you don't check. You give me extraneous solutions. Got to check.
That's nice. You don't have to actually do any math. You just
Look at your domain. Do the next one on your own.